This is graphing some rational functions from a bunch of our attributes. Okay, like our intercepts and asymptotes and limits of functions at different numbers. Okay, so we're talking about limits in pre-calculus. So first of all, we look at the domain. X cannot be equal to 2. Okay, so when we're talking about domain restrictions and the graphs of our rational functions, this can be one of two things. So this is either a vertical asymptote or this is a hole in our graph. Right, those are the only two things that happen if you have a domain restriction. We either have a hole at that x value or we have an asymptote at that x value. Now this next thing tells us exactly what we have. When the limit does not exist, that tells us we have a vertical asymptote at this value x equals 2. Okay, so this domain restriction is going to have a vertical asymptote here rather than a hole. So we can come over to our graph, right? Put 2 tick marks in the left side and the right side, that's where positive 2 is. And we can put our imaginary asymptotic line dashed vertically like that. We'll just put some more tick marks on here for fun. So if the limit does not exist at that restriction, that means we have a vertical asymptote at that x value. Okay, now these next two sections are telling us what the profile around our asymptote is. Okay, these are your profile questions. Looking to the sides of our asymptote. So this is the minus means to the left side. We're at infinity, so the graph is going to start up. So we can put that in there. On the left side of our asymptote, the graph has to be up here. Okay, going vertically on the left side. And on the right side, right, the little plus here means on the right side of positive 2, the graph goes down to negative infinity. So we're going to put a little arrow on the right side on the downward spot. Okay, so this is the profile of what our rational graph is doing to the left and to the right of our asymptote. Okay, so now we're looking at a couple extra things. This next one, let me change colors here. This is your horizontal asymptote. The limits to infinity are talking about your horizontal asymptotes. Okay, so that equals 1 means we have a y equals 1 horizontal asymptote. So once again, we come over here and you put an imaginary dashed line at positive 1, okay, as far off to the right and as far off to the left as you can. And try to make it as parallel to that x-axis as you can also. Okay, it just helps your brain when you're thinking about how to graph these things. Okay, 2 more attributes. Our f of 0, that's talking about the y-intercept. When x is 0, what is the y value? So it's positive 2. And then this bottom one is talking about your x-intercept. When your y value is 0, what is your x value? So we have a 4, 0 x-intercept, and we have a 0, 2 y-intercept. So we can plot these on our graph as well. So 0, 2 is right here, and 4, 0 is right there. So now that we have all of our information, we have to make our graph go through all these points that we have on our grid here. And to the best of our sweet little abilities, right? Sometimes our pencils don't work as well as we want it to, but you want to start up here at your asymptote and come down and make sure it goes through that y-intercept and then out towards your horizontal asymptote. Okay, so that's the top left looking quadrant, and then the bottom right looking quadrant, we start down here on the right side and we come up and go through your x-intercept and then make a right turn and go out towards your horizontal asymptote. Okay, now these are not streets, right? We don't make 90-degree angles. They're kind of curvy, and the curviness depends on how your pencil goes. Okay, I'm not going to grade you on your perfectness of these sketches, just that you put the right spots with the right attributes, right? Your asymptotes and your intercepts and things like that. Okay, so don't go for perfection. We're just going for pretty okay. Okay, so here's a second example. Here we have two domain restrictions. One is at -1 and one is at +2. Okay, so that's going to see here. Notice at +2 we have a y value. Okay, so this is going to tell us our graph will have a hole at the point 2, 1. When we have a domain restriction that also has a limit, okay, that is going to tell us we have a hole at that point. The x is a 2 and the y value at when x is 2 is +1. Okay, so if we have a domain restriction with a y value, that's going to give us our hole in the graph. Okay, so the other one is telling us we have a domain restriction at 1, but the limit does not exist. Okay, so when the limit does not exist, that's our vertical asymptote at this x value. So at -1, we have a vertical asymptote. Okay, there's also some clues here. We wouldn't have a profile unless we had a vertical asymptote anyway. So that's a pretty dead giveaway that you have an asymptote at -1 because you have the profile on the left and the right of -1. Okay, and that only occurs if you have a vertical asymptote. Okay, so let's put that vertical asymptote in here at -1. We'll deal with the hole in a second. So here's your vertical asymptote through -1. We might as well put some more x values on here. -1, -2, 3, 4, 5. Okay, do your best if you have a grid to evenly space them. It just helps your brain to see it as being correct. Okay, so the profile on the left, once again on the left of -1, the graph is going up to infinity. So we can put that in here on the left of our asymptote. It's up there, and on the right of the asymptote, it's down at -infinity. Okay, so we put two arrows to remind us of the profile of what's happening around that asymptote. So our next one limits to infinity. This is your horizontal asymptote. Okay, and that has a y value of 2. So it has a horizontal asymptote at +2. So we can put that in here, all right, some little dashed horizontal lines. Being as straight and as parallel as you can get it to the x-axis, do your best. Okay, as you can tell, not all of mine are perfectly straight either, and I'm okay with that. So hopefully you are too. And then our two intercepts, right? F of 0 is your y-intercept at 0, -1. And here is our x-intercept at 0.75, 0. So 3/4, 0. Okay, so 0 minus 1 is our y-intercept. And 0.75, so let's see, that's in between 0 and 1 here. I can pinch my screen and make it a little bit larger. You probably can't pinch your paper, but it'll be okay. Okay, then the last thing I have to put my hole on here, so let's go back up here. 2 in the x and 1 in the y. So we'll just put a nice sized open, right, discontinuity right there. So now we have to make our graph go through these points. So there's a lot on the right side. We can start down here at -infinity and come vertically up along your asymptote, right? Try and hit the point 0, -1 and then 3/4, 0, as you also try and hit your hole right there at 2, 1. Okay, make sure you pick up your pencil and you don't draw a line through your hole, but that you leave it looking holy. Okay, do not fill that hole in. It is not a point. It is a removable discontinuity. Okay, so as such, it needs to have a hole. Okay, so that's the lower right quadrant, and the upper left will be sort of symmetrical, right? We don't have any definite points over here, so you just have to make sure your graph doesn't cross either one of your asymptotes. So there's our rational function, right? It has a 0.75 x-intercept and a -1 y-intercept. and a hole at 2, 1. Okay, so graphing from attributes. If we have a domain restriction that also has a y value, that's going to be a hole. Okay, this third one, notice, has 3 domain restrictions, -2, +2, and +4. Okay, so we have a restriction at +4 and we have a y value. So this is where our hole is going to be. Okay, when we have a restriction with a y value, that is your hole at 4, 1/2. Okay, these other 2 places at +2 and -2 do not exist, so these are going to be our vertical asymptotes. Right? They have profiles around them, so that also makes them vertical asymptotes. We would not have a vertical asymptote around a hole. So let's come over here and do some sketching real quick. We have a -2 and a +2 vertical asymptote. So let's put these dashed lines in here, making them as, that's +1, never mind, erase that one. We want it through +2, that's a highlighter. That's an eraser. That's a better eraser. Okay, here's +2. Here are our asymptotes. That looks much better. Okay, and then at 4, 1/2 is where we're going to have our hole. So you can put that in here also if you are confident that you can hit it later. So there's 4, 1/2 right there. Okay, so we have our profile next. Let's deal with -2 first. So on the left side of -2, the graph is up, and on the right side of -2, the graph is also up. Okay, we can do that, up on both sides, that's all right. And +2 on the left, we're down on the left of +2. So down here. And to the right of +2, we are at +infinity. Okay, so those are the profiles, up and up on -2 and down and up on +2. Okay, now it's looking a little strange. We have a horizontal asymptote, right, limits to infinity. So our horizontal asymptote at y equals 1. So we can go ahead and put that in here. Okay, and then let's see about our intercepts. We have a y-intercept at 0, 1. And we have an x-intercept at 1, 0 with a multiplicity of 1, so it will cross at +1. And x equals 3 with a multiplicity of 2, so it will bounce at the point 3, 0. Okay, from our polynomial unit, a multiplicity of 2 means the graph will bounce at that place. So let's see, 1, 0, 1. 0, 1 is the y-intercept. 1, 0 is an x-intercept, and so is 3. All right, so let's see what we can do with our graph. So the left side looks pretty easy. It starts at our +infinity profile and will go off towards the horizontal asymptote. Okay, nothing strange there. But here in the middle, right, we have to start up here, but yet go through both of these points. Okay, and I know that this is confusing because we were taught in Algebra 2 that you really shouldn't be crossing horizontal asymptotes, okay, which does in fact happen. In this case, it does for sure. The horizontal asymptote is really talking about what's happening for very large positive and very small negatives, right, way out here to the far left and the far right. That's really where the horizontal asymptote is living. It doesn't necessarily live in this area around our origin. Okay, so we have the profile, right, that leads us to make it look like this. And now on the right side, I have to come and bounce here, right? I can't cross my x-intercept, so I have to bounce and then come back up through that hole. Okay, so it looks like this one is going to approach its horizontal asymptote from below the horizontal asymptote, right? Which is something we might not have dealt with before, graphically speaking. So we're going to come down so that we bounce, right? We don't cross at positive 3. We're going to bounce there, and I can do that better. I can come all the way down to positive 3. There we go. And then it has to go through our hole at 4, 1/2. Okay, and now we're going to grow out to the right and now approach our positive 1 y-intercept from below. Okay, like I said, not something that we usually do, but as you can see, something that can happen. Okay, so sometimes the graphs look really strange, but according to our attributes, right, that's exactly what we need to have happen. So hopefully that clears things up with whether we have an asymptote or a hole at your discontinuity, right, or at your domain restriction, and then what the profile does, and whether we have intercepts or holes at different places.